Alright, so here's how the setup looks like when the SR-3 Dark is set up on my Phobia Wacool T bench table. So I really like this form factor when it's not too large. When the length is the same, it is just a bit wider. So this fits the bench table as well as many cases much better than those much larger board options from other manufacturers like the Dominus or the Aorus Extreme from Gigabyte. Now, thanks to Tin from EVGA for solving some small things about the board from my previous video. So the thing I thought at the back side of the board near the top part of the PCB, that is just a debug port. It is nothing related to M.2. There are only two M.2 slots on this board, as we could see from my overview video. So over here and over here. Sorry for my confusion about the U.2 ports for the virtual RAID on the CPU. So these are just U.2 ports for storage, but of course I haven't used them myself at all. So I don't have any experience with that storage connection. But yeah, so I think this way of mounting the water block should work. The pressure fit seems alright. The contact is pretty much it feels alright. I swapped the mounting frame for the CPU, and now there's like nothing blocking the contact of the water block, and it pretty much covers the whole of IHS. But since this is the narrow ILM, the mounting bracket of the water block blocks the first memory slots on this board as they are so close to the CPU. If this was 2 slots per channel design motherboard, this wouldn't be a problem, but on the Dark I cannot use all 6 memory channels with a normal water block like this, so I have to get the real 3647 narrow ILM water block that is specifically made for this platform. So now, for just quick testing purposes, I will use quad channel memory. I actually got a new memory kit which I plan to use on this board. I got the 4400 Cas19 Trident Z. I was pretty sure that it is the older A1 PCB, but sadly it seems that all the vendors are swapping to A2 PCB now, so even that is A2, and it really isn't good. It cannot even do 4133 with 12-11-11 timings, not even 4100 with Command Ray 1. That is really bad, so I will just return that kit. I need to find something else in the meantime while I wait for the real water block. But that's how the thing looks like. I will just use a simple graphics card to display the monitor signal. We don't need the 2080 Ti Kimpin for this testing purpose right now. So that's the Galax 710 GT, and you can see just 2 power cables for the CPU. So 24 pin plus 2 over here. Cannot run 4 from a single power supply, and I will just now I'll just clear the CMOS and I will go using a PS2 keyboard through a PS2 to USB adapter, because there's no PS2 port at the rear I/O of the spot board, which is very sad, but nothing can do at this point anymore, I think. But yeah, so without further ado, let's start the rig and let's take a look at the BIOS. B2. SR-3 Dark. And let's see how the BIOS looks like. So yeah, so it's pretty much identical as your normal X299 Dark BIOS. You couldn't tell the difference based on the front page. Of course, you can see the model name of the CPU, but yeah, so BIOS is version 1.03. So I think this is the initial retail BIOS. So I think as the first step we could test how it boots the operating system and check what are the temperatures and so on when just running the CPU at stock. So I will just set the oops, no. So I will set it to legacy because I will try to boot Windows 7. Alright, so I actually changed over to Windows 10 because of USB issues. So we can now, let's take a look at CPU-Z first. So here you can see CPU-Z, Xeon W-3175X, and you can also notice that this is a retail CPU. So this is not an engineering sample CPU, as you could guess on a user like me. So just quad channel due to the mounting bracket on the water block, and just auto mesh. SR-3 dark version 1.03 BIOS, so it's from November 25th. So yeah, I'm not sure at all that is this voltage measurement accurate, but we can test that out. I'll look at that massive core temp. So just out of pure interest, let's check the temperatures. Of course, it will be crazy fast. So the temperatures are from like higher 40s to mid 50s. The hottest core was actually, it was 62. I'm not sure if that's some error, but yeah. So the score at stock is 5460, but have to remember that it actually limits the overall score when I'm only having 4 memory sticks. So memory does affect the score of Cinebench R15. But for now, I just want to see that how well does the CPU do, just overall in terms of overclocking, because the memory doesn't really memory does not limit your maximum CPU overclock. So you will get the same end result speed no matter if you are running 2 sticks of memory, 4 sticks of memory, or 6 sticks of memory. So let's take a look at the BIOS now. And I think I will just leave the memories at auto first. There are no OC profiles yet included, as we haven't had time to make them. Manual. So we will start with the CPU multiplier control, manual ratio limit, and I will try. Hey, what's the stock speed actually? Was it 4 gigahertz? I don't know. Let's try 4.5. I'm sure it will do that. Mesh 3.2. 0 on the AVX negative offsets. Leave the extreme cooling and voltage mode disabled for now. We would have to enable extreme voltage mode if we want to run higher memory voltage. For the input I will run 1.9. It's 1.8 at stock, but all these CPUs are pretty much the same anyways. It doesn't, they don't differ at all. So you overclock them the same way. There's no question about that. Let's try 1.1 volts. I think it will do that. 1.20, 1.25 on the mesh. Right now I don't have Elite to change things in the OS, so we have to just do everything from the BIOS. Load line calibration for the input. So if you disable this, it will enable load line calibration for the input voltage. SA and S1, VCCSA and VCCIO are pretty much the same for sure as on Skylake X299. I will just put 1.1 on both of them. PCH I set at stock. Sometimes some motherboards change it to weird values when it's left at auto, so that is why I generally like to set the chipset voltages near the stock value manually. So we can let's leave memory and everything at stock. I will save this profile, test. So 4.5. Actually, I will just lower the mesh to 3 gigs just in case for this test. 1.9 input, 1.1 VCore, 1.25 mesh. But I really think this cooling solution is just fine. There's no issue with mounting pressure so far. Seems to work just fine. So yeah, it did crash. So I just want to make sure I want to play it safe because of my like ghetto cooling solution, and these CPUs just run hot anyways due to the large amount of cores. I don't have any idea of the accurate power consumption, but now it's set at 1.1 volts, 1.9 input and 4.3 gigahertz. So just let's check the temperatures. Already the hottest core is going to 80 degrees, so yeah, the variation is high from 57, but the hottest core is 79. I don't have any idea why, but one core is just so hot. But already, if you look at these temperatures with only 1.1 volts on the vehicle, that is absolutely, I mean, really high load. So that's why it's wise to play it safe. Do not set 1.3 volts straight away and try to get best speed with that voltage straight up. So have to play it safe. Remember, many of those guys just use like 1.35 to 1.4 volts when on LN2. So water, we have to play it safe, like really safe. So now we can push more. It was almost 62,000 score. So now it passed. I actually lowered the input to 1.8 volts. So yeah, doesn't really seem so that this likes high input straight away, but really this is an issue. Look at that. Core number, actually that is 18 because the 17th core is core number 18 because first core is number 0. But the 18th core is at 85 degrees maximum. That is really high. So that's the thing that limits my overclocking now. Otherwise I could push, yeah, I could push to like 1.2 volts. Of course I could try to remount the CPU, see if everything is alright under the hood. Score 6402. But yeah, looks alright. So other important parts of note about the BIOS. So the OC tab as well as the memory tab of the BIOS, they are pretty much identical with the Skylake X299 Dark. The only real differences I could find were some of those chipset voltages. So for example on the SR-3 Dark there are two different PCA voltages, so PCH 1.05 and 1.0 voltages, and then some PCH logic voltages, so VCCA CLK or clock and VCCA PLL. These are some chipset logic voltages according to the description of the BIOS. But the overclocking method is pretty much the same as on X299 Dark. When it comes to the memory part of the BIOS, so all the settings over here, they are pretty much identical as on X299 Dark. All the sub timings. So if you want some profile for pure overclocking tests, you can use my memory profile from my 1700X record video, for example. If you are just looking for like daily settings, you can start off with XMP, work your way up from there, and then you can just start with tightening the settings, so like 4000, 17, 18, 18, 28, command rate 1 or 2, depending on your memory kits, of course, because every memory kit is different. The silicon lottery affects memory as well, just like it affects CPUs. Then, when looking at the advanced part of the BIOS, we can go through these settings quite quickly. So CPU configuration, nothing that you should touch over here. So we have the speed stepping setting, turbo mode, C stage, hyperthreading, virtualization for directed IO, and you could disable some of the cores, every core manually, and then you can change the maximum temperature for the CPU. So it's funny when you can actually disable any of the cores individually. Previously with with previous generations you could just like let it choose what cores will be disabled. So you could just limit the maximum amount of cores, not disable cores individually. So this is something new. So you could just test which cores are weaker than the others. But yeah, so for daily use you don't have to touch any of these pretty much. CPU storage, nothing over here. PCIe. You can change the PCI Express generation of different slots. Only real case where you could touch these is if you run some old graphics card on LN2, for example 7970 Lightning or 7970 overall. It has Gen 3 support, but it has worse cope bug and cope boot bug when you run the newest generation. If you set PCI Express 2.0 or similar or older, it will get rid of those cold issues. So that's the only case when you would have to touch these. Nothing in PCH, SATA, can choose between AHCI and RAID. There's no IDE because, well, you will not run XP on a board like this, and it's not supported no matter what. USB, nothing over here pretty much. You have to keep legacy USB support enabled if you run some older operating system like Windows 7 for example. On onboard device configuration you can disable both of the LAN controllers, creative audio controller, USB 3.1 controller, U.2 ports, M.2s, etc. The hardware monitor configuration is important. So with these you can control the two onboard debug LEDs and decide what you want to monitor with them. First you can choose the orientation, so it depends on how you have this set up in your case. If it's if the board is not mounted the wrong way around, then you can just keep the orientation as normal. But if it's the other way around, so that the CPU part of the board is down and the PCI Express slots are at the upper part of the case, you may revert this to reverse so that you can read the values correctly. And I would say that you should monitor the PWM temperature, so the VRM temperature on the motherboard. You can monitor the CPU temperature better with real software like Core Temp. Usually those programs are more accurate when reading the CPU temperature than the debug LED. But this is the easiest way to monitor the VRM temperature on the motherboard. So set this to PWM if you want to monitor the VRM temperature. So actually, is there CPU die? Well, can't find it. Yes, so apparently there's no CPU die monitor anymore. That's a bit sad, because that was so handy for extreme overclocking. I'm not fully sure if it will be enabled with later. I mean, with BIOS updates later, because that's very sad if it doesn't exist on this board. I'm not fully sure if the CPU temperature actually means the CPU die, but if it means the CPU die, then don't use this to monitor the actual cores. Use Core Temp or similar program to monitor the CPU temperature, and just use this for the VRM. And nothing in trusted computing that I would find that important, and the NVMe information page only shows your potential M.2 devices that you have installed in your system. And in the boot tab, select UEFI if you are installing Windows 8, 8.1, 10 from a USB, and set it to legacy if you are installing Windows 7 or even Windows 8 or 8.1 from a DVD. So that's the difference between the two. And then you can just select the boot order at the bottom of this page, and in Save and Exit you can save the profiles over here and load them. So that's how the BIOS looks like pretty much. In the extras you can find the BIOS update function and similar, and as well as the OC rollback OC robot, so you can let the BIOS of the SR-3 dark to manually test the overclocking potential of your CPU. I will make a separate video about this feature as I haven't used this, and there's even a stress test in BIOS. But if you want to update the BIOS, just go to the bottom option in the extras section. If we apply any overclocking profiles to the BIOS in later BIOS updates, they will show up over here as well. So that's all of the BIOS pretty much. Alright, so now after testing a bit, I found out how the board pretty much works. So the highest core frequency I managed to run with this particular 3175X Xeon is 4.7 GHz. So that is not that high, to be honest. I'm not fully sure if this CPU has been binned at all, I don't know. But anyways, the temperature is the limiting factor no matter what. But I got up to 4.7 in Cinebench, etc. with like 1.23 to 1.24 volts. The funny thing about this CPU is that it doesn't matter what input voltage you use. The end result, at least of water, is the same no matter if I set 1.7 or 1.9. So I just kept it at 1.7 to save a few degrees in temperatures. When it comes to mesh, the maximum this can do is 3.3 GHz with 1.35 set on the mesh voltage, and 3.2 is quite rock solid at 1.25. So this is kind of the range I would try when it comes to the mesh clock. What I don't like about the dark, I'm pretty sure this is the issue with most motherboards, is that the boards drop memory channels quite easily. So you can easily determine it, at least on the dark, when you look at the total size over here. So now when I'm only running 4 sticks, it should read 32 gigabytes. Sometimes the LED on the board points out immediately if some of the channels or DIMMs has failed posting by the LED turning red on the corresponding memory stick. But sometimes it doesn't show up red and you still have less memory available in your system than you should be reading. So that's one annoying issue, but it seems to be an issue with all of the 3647 boards out there. But when it comes to the memory, the best and most solid memory configuration I was able to run was 3800 megahertz with relatively high voltage, because I was running 12, 11, 10, 24, 4, 6, 6, 6, 12, 9, and command rate 1, of course. And the sub timings are the same as on my X299 overclocking videos. And funny, when I ran these settings, so these memory settings and these settings for the CPU, I was able to get a score of 7015 in Cinebench R15. And when I compared that to the other guys online, when I looked at HWPod, for example, there were 2 guys at around the same score on water, like Massman and someone from the US, and but they were running 4.9 gigahertz on the CPU, and they were running on Asus Dominus motherboard. So I'm pretty much getting the same performance with 200 megahertz lower core frequency. So that is really nice result for the dark. So the performance is there, obviously, but of course you need a CPU that clocks really well. My issue is the temperature. The 18th core is going way too hot. On those runs, it rose up to 101 degrees, so over 100 degrees. So that is not that safe anymore. So I need to get a better cooler, and I need to see if the IHS is in perfect shape, because the lapping process seems quite like non-finished. So I might do it a bit further with myself, and but that's pretty much it, because the 18th core is just like 10 degrees hotter than the second hottest core, so that is not normal. So if I got temperatures down to like more even level, it should do at least 4.8, I'm pretty sure. This CPU, I mean, with 1.28 something volts. It's quite okay, but the real test will be, of course, when I try the CPU on LN2. So the task is high because, the task is hard because the best CPU out there was doing 5.6 something for Siemens R15. So the step from 4.7-ish, from 4.7 to 4.8-ish to 5.6 plus is really hard and far. But of course I will try it. I will try the SR-3 Dark and this Xeon on LN2 after New Year, and I will just now wait for the real water block, because this doesn't seem this quite dodgy method of running the CPU with the normal water block, which is meant for the mainstream socket and the 2066. But yeah, so other than that, when it comes to the BIOS settings and overclocking, it is 100% identical to Skylake X X299 CPUs. Absolutely no difference between the two platforms. So if you get the SR-3 Dark, it will be very easy. You can try these settings yourself, if you, for testing purposes. But when it comes to like daily overclocking, you really have to start with a low voltage of 1.1 or something similar to that, because the temperatures go up really fast. I will be creating some overclocking profiles for this board, but other than that, of course, this will not be as popular as the Z390 Dark, for example. So I'm not expecting that all of you guys will be going out and buying this board and the CPU, because this combination is really expensive overall. For daily, when it comes to memory, you should be trying something like 3600 to 4000 plus with 17, 18, 18. Usually 4000 with 17, 18, 18 timings should be very easily doable if you have decent sticks. But that's pretty much it. So that's my short report on testing the BIOS and overall functionalities of the SR-3 Dark and how the CPU overclocks. Although I was not able to run all 6 memory channels because of my cooling solution, it already shows enough. So thanks for watching this short video, and I'll see you on the next one.